Hey class, this is going to be 12-4 quadratic functions. We're going to be taking a look at a few applications with quadratic functions. So we're going to apply quadratic equations to real-life applications. Now if you recall that profit for a product is defined by the equation profit equals revenue minus cost, or P of x equals R of x minus C of x. So we're going to go back to some of our business type applications. And it says the weekly revenue in dollars made by selling X portable game systems is R of X equals negative 1.5x squared plus 250x, with restriction that X has to be between 0 and 166. The cost in dollars to produce X portable game systems is giving, so this is my cost equation, 80x plus 150 for X is greater than or equal to 0. The first thing it's asking us to do is determine the weekly profit function P of X. So if I know that P of x equals R of x minus C of x, I just need to plug in what R of x is. So we said R of x is this. And I need to plug in what C of x is. And we said C of x is this. So R of x minus C of x. Now I have to distribute that negative through, and then when I do that and combine like terms, I get this statement here. The only thing that we have to remember is we also have to include the domain. So it's only valid on this domain right here. And so that is still a valid domain for what we're doing. Now the domain could change based on this equation, but we just have to remember that valid domain there. Number 2, it says graph y equals P of x. We need to include x and y intercepts, the vertex, and the axis of symmetry. So let's find those x and y intercepts first, because that's going to be much easier to be able to graph once we do that. So to find my x and y intercepts, well, for my x intercepts, we have to set our function equal to 0. Now when we do that, I get this statement here, negative 1.5x squared plus 170x minus 150 equals 0. When we're solving a quadratic equation, we said there were 4 ways to solve it, and I said mainly pay attention if you're able to factor it. If not, use the quadratic formula. Well, because of this 1.5, I can't factor it, but I can use the quadratic formula. So identifying what my a, b, and c are, I plug it into my quadratic formula. Now when I simplify it, I'm going to get 170 plus or minus 20 root 70 over 3. So those are going to be my x values, and so now writing them as points, I have 70 or 170 minus 20 root 70 over 3, and then 170 plus 20 root 70 over 3. And then my y values are 0 because I'm writing them as points. Now to find the y-intercept, I plug in 0 for x. Now if I do that, this goes to 0, this goes to 0, and I'm only left with 150, negative 150. So creating a point with that, I get the point 0, negative 150 as my answer. Now continuing on here, it says graph y equals P of x, and so I need to do that, but also said we should look at the inverse, or the vertex, and the axis of symmetry. So finding the vertex, we said we were going to use the equation negative b over 2a. So my equation negative b over 2a, my a was negative 1.5, my b was 170. So plugging in that into my negative b over 2a, I get 170 over 3. Now it's kind of difficult to think of things in terms of 170 over 3. So I'm eventually going to simplify that into 56.67 if you enter that in your calculator. Now evaluating, I got to find my y value. If I take this and plug it in for x and simplify this statement, then I'm going to get my y value, which is 4,666.67. And so these two represent my vertex. Now if I look at this graphically, if you also notice, that vertex is my maximum. And so that's going to be something that we're going to take a look at later. But notice I labeled, there are my x and y intercepts, there's my another x intercept, there's my vertex, and I drew in my axis of symmetry, which makes both of these graphs perfectly symmetric. Now it says interpret the zeros of P. So those zeros that we got, now remember it was like 70 plus 30 root or 20 root 70 over 3 or whatever that was. These previous values, all I did here is I just took these and I simplified them. And then when you enter those into a calculator, what's going to end up happening is you're going to get decimals. So 0.89 and 112.44. And that's when P of x equals 0. So that's all I did was just enter in my calculator. And so entering in my calculator, that just means that those are going to be the break-even points. So if I use this value or this value It's where my profit's going to be 0. And if I want to think of things in like, well, what region would I get profit? The inequality P of x is greater than 0 is going to represent where you make a profit. Now interpreting the vertex of the graph, y equals P of x. That vertex represents my max or min. And so this value right here, that's going to be the maximum way that I can get my profit. And so this is the maximum profit I can achieve. Now the only issue here is, how do I sell 56.67 Portaboys? You can't. So because of that, I have to kind of do some approximations. So I have to say, well, if I can't sell 56.67, well, let's see what it looks like if I sell 56, or if I round up, let's see what it looks like if I sell 57. So entering both of those into my calculator, I get 4,666.5. And so this here, this is going to be my traditional, or this is going to be what my max is going to be for this instance. So my max profit is going to be $4,666.50. Then number 5, it says recall that the weekly price demand equation for Portaboys is P of x equals negative 1.5x plus 250. Now, if you get where P of x is the price per Portaboy in dollars and x is the weekly sales, what should the price per system be in order to maximize profit? So if we said this is my price demand function, which means that's the price that I should sell to get that expected demand. Or if I want a certain demand, plug that value in, I want to sell this amount, this is the price that I should sell it for. And so we said that the way that we maximize profit is to sell 56 of them. So if I put in those 57 of them, if I plug in 57 and simplify that, I'm going to get $164.50 as my result. And so the price should be set at $164.50. Okay, so this next example says, much to Donnie's surprise and delight, he inherits a large parcel of land in Ashtabula County from one of his estranged relatives. The time is finally right for him to pursue his dream of farming alpaca. He wishes to build a rectangular pasture and estimates that he has enough money for 200 linear feet of fencing material. If he makes the pasture adjacent to a stream, which means no fencing is required on that side, what are the dimensions of the pasture which will maximize the area? What is the maximum area? If an average alpaca needs 25 square feet of grazing area, how many alpaca can Donnie keep in his pasture? So let's draw this out. So let's say this is the river, and that's his square footage. We can say that here's my widths and here's my length. I don't know. I mean, I think that's kind of fair. It says that we have 200 linear feet of fencing. Okay, so that sounds like perimeter. So in this case, my perimeter would be 2W plus L, which is 200 equals 2W plus L. And then the other one needs 25 square feet, so that sounds like area, and maximize area. So I also need an area equation, so area equals length times width of any rectangle. So now what I'm going to do here is I have a system of equations here, and so maybe I'm going to have to do some substitution, and if I subtract the 2W, I'm going to get 200 minus 2W equals L. So now I can plug it back in. So area is going to equal 200 minus 2W times W, which is going to be, I guess, area in terms of W would be minus 2W squared plus 200W. So there's my area equation. So now if I wanted to find what my, it says, let's see, if that's my equation there, it says what are the dimensions of the pasture which maximize area. So we're looking at the maximum. So if I'm trying to maximize area, or if I'm trying to look at the maximum, we do negative b over 2a. So negative b over 2 times a, which is negative 200 over negative 4, which is 50. So my width equals 50. Now to find what my area is going to be when my width is 50, I have to plug it back in, and so that's going to be negative 2 times 50 squared plus 200 times 50. So now entering that into my calculator, negative 2 times 50 squared plus 200 times 50, that's going to give me 5,000. So that is going to be my maximum. So the first question that it's asking is, what are the dimensions of the pasture which maximize area? So I need to find what the dimensions are first. So if I know that my area is 5,000, and that's going to be length times my 50 width, I have to take that 5,000 and divide it by 50, so my length is going to be 100. So the first part of the question is my length is going to be 100, and my width is going to be 50. It says, what is the maximum area? The max area is going to be 5,000 square feet. And then it says, how many alpaca can Donnie keep if an average alpaca need 25 square feet? So that means I have to take this 5,000 area and divide it by 25. And so if I take the 5,000 area divided by 25, because it's 25 square feet per alpaca, that means I'm going to have 200 alpaca. So those are going to be the answers to every single element there. So this concludes our lesson. If you guys have any other questions, please leave them in the comments.